This question is from the GATE Physics paper 2021. This is a numerical answer type question having 2 marks. The topic of the question is quantum mechanics. The question is the spin S vector and orbital angular momentum vector, that is L vector, of an atom precedes about the total angular momentum vector, that is J vector. Now the total angular momentum vector, that is J vector, precedes about an axis fixed by a magnetic field B1 equals to 2B0 along the z-cat direction, where B0 is a constant. Now the magnetic field is changed to B2 vector, that is another magnetic field vector, equals to B0 times x cap plus root 2 y cap plus z cap. Given the orbital angular momentum quantum number L equals to 2 and spin quantum number S equals to half for the particle. Here theta is the angle between B1 vector and J vector for the largest possible values of total angular momentum quantum number J and its Z component Jz. The value of theta in degree rounded off to the nearest integer is, so we have to find the value of theta here. It is given in the question that orbital angular momentum quantum number L equals to 2 and the spin quantum number S equals to half. So the total angular momentum quantum number J equals to from L plus S to mod of L minus S. So the values of J will be in this range. So the possible values of J will be in the range of 2 plus half to 2 minus half, because here L equals to 2 and S equals to half. So if we just want to find the possible values of J, then it will be in the range of these two quantity, these two number, and the possible values of J will be 5 by 2, 3 by 2. Here the largest value of J equals to 5 by 2. Now for J equals to 5 by 2, the possible eigenvalues of Z component of J, that is Jz, will be Mj equals to from minus J to plus J. So it will be 5 by 2, 3 by 2, half, minus half, minus 3 by 2, minus 5 by 2. Now the magnetic field B1 vector is along Z axis. The angle between the largest value of J and B1 is theta, that is given in the question. Now projection of the J along Z axis is basically gives us the Jz component. So we can write Jz equals to mod of J times cos theta. Now the value of this Z component of total angular momentum vector, that is Mj times h cut, and this value of total angular momentum vector, that will be root over J into J plus 1 times h cut, and here this cos theta is coming due to the projection. So the cos theta is Mj by root over J into J plus 1. What we have is cos theta equals to Mj divided by root over J into J plus 1. Now from the previous slide, we have the value of J equals to 5 by 2 and Mj value equals to 5 by 2. If we put that, we'll get 5 by 2 divided by root over 5 by 2 times 5 by 2 plus 1. So it will give 5 by root over 35, which leads to 0.845. So our theta is cos inverse 0.845, that is 32.31 degree. So this is the angle between the total angular momentum vector J and the magnetic field B1 vector, that is 2B0 z cap. So the angle between largest value of J and B1 vector is 32.31 degree. Now the magnetic field is changed from B1 vector equals to 2B0 z cap to B2 vector, that is B0 times x cap plus root 2 y cap plus z cap. So basically the magnetic field vector direction has been changed, but the magnitude of the two magnetic fields are same. because it has a magnitude 2b naught, and also the mod of b2 is also 2b naught. Now the angle between the two magnetic fields given in the question, that is b1 and b2, is phi. So we can write from the dot product formula, that is cos phi equals to b1 dot b2 divided by mod of b1 times mod of b2. So it will be 2b naught z cap, and it will have the dot product with b naught times x cap plus root 2 y cap plus z cap. And the magnitude of the b1 is 2b naught, and magnitude of the b2 is also 2b naught. So from here we can write cos phi equals to half. So phi will be cos inverse half. So it will give us 60 degree. So basically the b2 vector is making an angle 60 degree with the old magnetic field vector, that is b1 vector. So now our z component of the total angular momentum vector will align along the b2 vector. So previously it was at the angle 32.31 degree with b1 vector. So the angle between largest value of j for the largest values of total angular momentum number j and its z component jz and b1 vector, which is changed from b1 to b2, will be, we have to add that old angle, that is 32.31 degree, with the this angle, that is the angle between b1 and b2, that is 60 degree. So we'll get the new theta, that will be 60 degree plus 32.31 degree, that is 92.31 degree. So the value of theta in degree rounded off to the nearest integer is 92 degree. So the range of the answer will be 92 degree to 93 degree. So from the solution we found that the value of theta, that is the angle between the total angular momentum vector j and the magnetic field vector b vector, is either 92 degree or 93 degree, because it has a range from 92 degree to 93 degree.